have this atom, and this atom has a nucleus. And this nucleus must have either one proton or two protons and three protons, any number of protons, because there could be elements with different atomic numbers. There could be elements with different atomic numbers, yes or no?
Yes.
So when we have elements with different atomic numbers, so let the atomic number be Z. And Z means Z protons. Take care. Z means Z protons. Yes or no? So here
Yes.
we have Z protons. Are you understanding? Right? And but the electron is only one. The electron is only one. Okay. So the first rule on which the Bohr's model was based was number one, the Coulomb's law. Was Coulomb's law. Now, what does Coulomb's law states? Coulomb's law states that Coulomb's law states that understand. Now we know that at Mark that if we have 1 plus q1 charge and if we have q2 charge, yes or no?
Yes.
So we know that positive charges and positive charges repel each other. And we also know that minus and minus also repel each other. But plus and minus attract each other, isn't it? So
Yes.
when we know this part, when we know this particular part, what exactly does that mean? Tell me. What exactly does that mean? That that here the proton is positive, the nucleus is positive, isn't it?
Yes.
And the electron is negative. So when the proton is positive and the electron is negative, so definitely there is some force of attraction between these two. So if there is some
Yes.
force of attraction, you tell me one thing. Electrons, not just single electron systems. It could be any atom, but that the protons, let's suppose a nucleus has 10 protons. So we know that the atom will have 10 electrons as well to keep the atom neutral, isn't it? Right? But the
Yes.
protons,
But if it's not neutral.
no, just to keep it neutral, my point is understand. But we have these protons here, right? In these protons are accumulated at one small space, isn't it? They are all accumulated at one point, and a nucleus is very, very small inside the atom. So do you not understand that, whose strength do you think is more? The protons, which are accumulated at one point, or the electrons which are scattered? Tell me, whose strength is more?
No.
The protons accumulated at one point, they behave as 10 protons together.
Proton.
Exactly. So the nucleus is very, very dense. I hope you're understanding. The nucleus is very dense. You understand my point? And because the nucleus is very dense, so there are electrons as well. But these electrons which are in the outer shells are very, very scattered. So basically, the impact of nucleus is more pronounced on the electrons, isn't it? Just like the Earth's impact. Everything moves towards the Earth. Are you understanding?
Yes.
Everything moves towards the Earth. So my point here is that when everything is moving towards the Earth, what exactly do you think would happen? Tell me. What exactly do you think would
It
happen?
will fall into the
Everything falls into the Earth because the Earth's density is very high. Earth's core is very dense. On the similar lines, when I'm talking about, you know, the Coulomb's law. So Coulomb's law also states the same thing. Coulomb's law states that, the two charges, when you place them nearby, there will either be a force of attraction between the two charges or there will be a force of repulsion between the two charges. Either the two charges will repel or the two charges shall attract. You understand? And whenever the two charges are attracting or repelling, whenever the two charges are attracting or repelling, that's when there is a force between them. And that force depends upon how close or far these point charges are. You understand my point? If the point
yes.
charges are close, the force will be more. And if the point charges are far, the force shall be less. Do you understand my point? Okay.
Yes.
So the force is going to be K Q1 Q2 over R square. That means the force is directly proportional to the product of the charges. Okay, the force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Which means what? If you increase r, if you increase r, that means if you take the charges away from each other, if you take these charges away from each other, right?
Yes. Then the force will decrease.
Decrease. Decrease. So that means r increases, force decreases. This is called inverse proportion. This is called inverse proportion. Are you understanding my point?
Yes.
So, what is the concept? So, when we are talking about the inverse proportion, and then what does it say? That more the charges or the more the value of the product of the charges. So, more the charges. That means if this is 2 coulomb and this is 3 coulomb, so there must be some force between the two bodies, the two charges. But if it becomes 20 coulomb and if it becomes 40 coulombs, definitely the charges are increasing. And definitely, if more charges are increasing, the magnitude of the charges is increasing. Don't you think that there shall be this more amount of force between the two charges? No matter if it is
Yes.
an attractive force or if it is a repulsive force. Tell me. You understand the point?
Yes.
So that is the concept. So when we are talking about the Coulomb's law, okay, when we are talking about the Coulomb's law and the more amount of charges that we have right here, okay, so 20 coulomb and 30 coulomb. You understand my point? So
Yes.
what exactly do you think would happen? So we have 22 coulomb and we have 3 coulomb, and this is Q1 and this is Q2. So the force is directly proportional to the product of the charges. So more the charges value, the more the magnitude, more the product, more shall be the force of attraction or repulsion between the two charges. Are you understanding?
Yes.
Okay. So that's the concept. So when we are talking about more the charges, more is the force of attraction. Understood or not? Right?
Yes.
So that is one concept. Now here, what do you think we have? So force here is going to be K Q1 Q2 over R square. That's the Coulomb's law. Okay. Now, understand. So, how would I write it down? K is K. What is my first charge? My first charge is electron. And my second charge here is the nucleus. Yes or no?
Yes.
So, the nucleus charge would be Ze. The nucleus charge here would be Ze. You understand? Over R square. What is R? Because they are R distance apart.
R is the distance.
Exactly. R is the
Radius.
distance. Correct. From the center of the nucleus till the electron. And we can also say that R is also the radius of what? R is also the radius of R is also the radius of the shell
Circle.
shell in which the electron is residing. Okay, in which the electron is residing. Are you understanding my point? Okay,
Yes.
so that is one concept. Now you understand a very simple concept right here. So when we are talking about the Coulomb's law, right? So this is Coulomb's law. So the force between the two, and this is who. What is the direction of this force? It is acting inwards. It is acting inwards towards the center. Okay, it is acting inwards towards the center. Understood or not?
Yes.
Okay, so when it is acting inwards towards the center, so we have Z, E, and E. Are you understanding the concept?
Yes.
Okay, now understand. So here, if we have these electrons, right? So what is the direction of the force? Inwards. Now, another force is acting here, which is called as a centrifugal force. Which is called as a centrifugal force. Okay. Now, what is the centrifugal force? Just understand. This electron is moving, right? So when you move something, in a circular path, where do you think your hand experiences the force? Don't you think that that it's like the body tries to move out. The body wants to fly outside, because it is
Yes.
rotating at such
Want
a
to go
fast
in a
speed.
straight line.
Yeah. But if we stop it, it would
We
go
need to
tangentially.
constantly apply force to keep on changing the direction of the ball.
Exactly. So that's why we have to pull it inside as well. But to every action, there is an equal and opposite reaction. So the reaction is towards outside. Yes or no?
Yes.
So my point is that there is this R inside, there is this force inside, and that is my attractive force. And you understand that, if the electron would have been at rest, then this nucleus shall pull this electron inside. Then that nucleus shall pull this electron inside. And when that nucleus shall pull this electron inside, what would happen? You tell me. The
Then one of
electron,
the protons will become a neutron.
exactly. And there a lot of energy would be produced. There would be sparks everywhere, but that's not happening. So, what is holding it on its place? So, there is an outward centrifugal force as well. There is an outward centrifugal force as well. There is an outward centrifugal force. Okay. And that force is like the faster the electron moves, the faster the electron moves, the faster that outward centrifugal force goes on increasing. And the formula for the outward centrifugal force is mv square over r, where m is the mass of electron, v is the velocity of electron, and r is the radius of electron, radius of the shell in which the electron is residing. Do you understand? Okay.
Yes.
This is the formula for the outward force that this electron will be experiencing. And why is this electron experiencing this force? Because it is rotating on this circular path. Are you understanding my point? Just tell me.
Yes.
Okay? That is the concept. That is the concept. Do you understand this?
Yes.
Now, what exactly do you think is happening here? So we have this. Now, what is happening? Just see. When we have this thing, so I say that the electron is moving on its own path. What do we say? That there are protons, Z protons, and there is one electron because we are discussing the hydrogen atom, which is made for only one electron. So I would say that, to keep the electron on its own path, to keep the electron on its own path, okay, there has to be there has to be an inward attractive force and the outward centrifugal force, both must be equal. So what is the formula of the inward attractive force? What is the formula of the inward attractive force? The inward attractive force formula here shall be kze square over r. Yes or no?
Yes.
Would be kze square over r. And the outward centrifugal force shall be mv square over r. So if I say, so mv square over r would be equals to kze square over r square. Because
Yes.
why ze square? Because it is k q1 q2 over r square. So the distance between this is r. You understand? And
Yes.
ze is the nucleus charge because one proton's charge is also equals to the charge of one electron. But here in the
Yes.
nucleus,
But if there are more protons,
yeah. So this
then the
expression,
inward attraction will be
exactly
greater and the electron will orbit closer.
correct. So this is my Bohr's first equation. This is my Bohr's mathematically. This is my first equation that Bohr gave. Okay, this is one thing. Do you understand my point? Right?
Yes.
I hope you're understanding. Okay, can I move forward now? This is little bit at a higher end I'm going. But if you wherever you feel you're not understanding, I will stop it right there. But do you understand that up till now? Did you understand
Yes.
this equation, Mark? Right? Okay. Now you see what exactly do you think we have? Now see, we have the nucleus. Okay. Now there is one term which is called as momentum. Momentum. Now, there are two types of momentum, okay? There are two types of momentum. One is called linear momentum. One is called linear momentum. So, we were supposed to discuss this term, and one is called angular momentum in physics. So, this quantum, by the time you reach quantum, both of your physics and chemistry would be mixed now. Understand? So, when we are talking about the momentum, okay, momentum basically means what?
It means the inertia.
Yeah. Momentum means the destructive capacity. The destructive capacity that a body possesses. It's like, I would say, this word can be used in multiple ways, okay? Like, for example, we can say that, the bullet moving at a very high speed had a high momentum. And now you imagine that if bullet strikes a body or if a bullet strikes a person, so what would bullet do to that particular person? Don't you think that the bullet is just going to pierce off the person's body and, pierce off the object on which it is
Yes.
striking? So my point here is that, if this momentum, we are talking about the momentum, so momentum has a destructive, the momentum means the destructive capacity. Now you tell me, there is a street. On this street, we have two vehicles, two cars, let's suppose, two heavy cars, right? Now one car is moving at a speed of 100 kilometers per hour and another car is moving at 10 kilometers per hour. And you are standing here. You will get scared by which car, A or B? Who do you think
B.
is going to be more destructive car?
B.
B. And let's suppose I'm saying that, the two bodies.
I thought that the momentum is the power at which it will keep on going if the motor is shut down.
Huh?
I thought it's the resistance to
No, that's
force.
inertia. That's inertia. Now you listen, keep listening. So what I'm trying to tell you is that, when we are talking about the cars, the two cars were exactly the same, isn't it? And when
Yes.
the two cars were exactly the same, what exactly do you think it would mean? Tell me. So when the two cars were the same, okay, but one was moving at 10 kilometers per hour and one was moving at 100 kilometers per hour. So what do you think would happen? You got scared with car B because you know that, the car B could be more destructive.
Yes.
So what did I do? I kept the mass same. I kept the mass same because the two cars were identical. But I changed their velocities, or I changed their speeds. So the velocity, which one would have higher velocity, would have higher momentum. Are you understanding my point? The one
Yes.
which had higher momentum had higher velocity. And when we are talking about the other two things, now let's suppose I have a cycle and a car. Now both cycle and a car moving at the speed of both cycle and the car moving at the speed of what?
100.
100. But now this is Mark. So who do you think will scare Mark more, the cycle or the car?
The car.
The car. So here, definitely the cycle, no matter how heavy the cycle is, but still that cycle would be lighter than the car. And thereby, even if the velocity is the same, even if the velocity is the same, the mass matters a lot. So, on two bases, the body could be destructive. Either the mass of the body is more, like you will not be scared by, let's suppose, a cat, but you will be scared by an elephant. If both of them are rushing towards you to catch you, you will be scared by an elephant more, right? So my point is that
Yes.
more the mass, more is the momentum, and less the mass, less is the momentum. That means the destructive capacity. But now the point is that, it's up to the person. It's up to the person. I could use a bullet to kill somebody, or I could use a bullet to, pierce the wall so that I can do something with that hole that I've created in the wall, isn't it? So it's up to me, how
Yes.
am I using that destructive capacity? But it's like that, how much motion is contained in the body. So the definition is, how much motion is contained in the body what could you do with that motion? You understand my point?
Yes.
So momentum, which is P, is denoted as the product of mass times velocity. You understand? Momentum is denoted as the product of mass times velocity. That is momentum. Do you understand my point? So P equals to
Yes.
mv. Understood or not? Okay, that is the concept. So when we are talking about P equals to mv, that is my momentum. Okay, that is momentum. Now this is linear momentum. Why? Because the car is moving in the straight line. The cycle is moving in the straight line. So this is linear momentum. Nani? Nani? This is linear momentum. Yes or no?
Yes.
Right? But now here I'm going to discuss about the nucleus, right? So we have Z protons here, and we have this
It's
electron right here.
angular because there is a force that is bending the line, the inward force.
Yeah, yeah, exactly. But you understand, so every time to bend it inside, there is a force, right? But you
Yes.
realize that this is moving also. So this is moving in a circular path. So the circular path, it will have some velocity, angular velocity, some linear velocity. And it is moving in a path of radius r. So my point here is just understand for the basic meaning of momentum that either the body is moving in a straight line or the body is moving in the circular path. The motion in both the situations could be destructive, isn't it? If you ride a bicycle in a circular path, couldn't that motion be still destructive,
Yes.
right? So basically, the amount of motion contained in the body or the destructive capacity. Understood or not? Right?
Yes, but you have to apply a force to steer the bicycle in the circular path.
Exactly. That is why change
If
in
you let
momentum.
go of the steering rod, it will go in a straight line.
Correct. Right. Now you understand. So what I'm trying to tell you is this. Understand. So this is one part, right? Now the formula is mass into velocity. This is linear momentum. That's the formula. So linear momentum we denote with P. Now what is mass? Mass we have understood as the mass is a measure of inertia. Mass is a measure of inertia. You know what is inertia? The resisting property. If you're sitting at a place and you want to keep sitting at a place, but if somebody moves you, you will resist that motion. You know, you would not like to move. Are you understanding?
Yes.
So if you would like to resist that change, what exactly do you think would mean? Tell me. So
If
if
you
there is a
resist the motion, then
exactly.
it,
Yeah,
it will be less.
you can just connect back in 10 minutes, Mark. Okay. So my point is that it is a measure of the inertia. Yes or no?
Yes.
Right? Now, so mass is the measure of inertia, v is the velocity. So we can say that every momentum is nothing but just the product of the measure of inertia. And which inertia? Measurement of inertia in straight line. Measurement of inertia in straight line. Then how fast this mass could actually move. Understood or not?
Yes.
If it is a lighter mass with just little bit of push, you can move the mass. So you will say the mass is giving you least resistance, least inertia resistance back. If you are pushing it and the mass moves faster, the mass is not moving, it is a heavier mass, then you will say it has a higher inertia. Now let's talk about the angular momentum. What is angular momentum? Understand? Now you tell me, Mark. Let's suppose we have the circle and there's a certain mass m, and this is the nucleus. So what would that mean? You tell me. So we have this nucleus and not just nucleus, any circular path, and this electron or some body object m is moving. Now you tell me where it is easier to rotate a body. Let's suppose I take a thread, okay, and I take a smaller thread and I tie a ball with it and I want you to rotate it. Would it be easier for you to rotate or would it be difficult for you to rotate?
Easier
Easier. If I take a long thread and then I want you to keep it straight but still rotate, then would this be easier for you?
No.
No. Basically, the moment you say that
Yeah,
you
but the very small thread will be harder because it will get stopped by our fingers.
yes, but it'll be difficult to keep it rotating, you know. So that means that the mass is still the same, m mass, but rotating it one in a smaller radius and rotating one in a bigger radius. You understand? So rotating one in a smaller radius and one in a bigger radius. So what do you think would happen? So if you're rotating it like this, in the circular path, so do you not understand that there is a resistance? There is a resistance imposed by the radius as well. There is a resistance of rotation. That in certain cases the rotation or the revolution is easier, and in certain cases the rotation or revolution is difficult.
Yes, because farther away from the center, it's moving faster.
Yes, it's moving faster.
Like if you have some kind of ball that can be slided on different sections of the same string,
Yeah.
at the end of the string, it will have to move faster, and in the
But to move at the same speed, it would require more force, isn't it?
yes,
I'm not saying it's difficult, but I'm saying to move at the same speed, it would require more force. So, do you understand my point? So, easier it is would be on the smaller circle. So, now when we're talking about this rotation part, okay, when we're talking about this rotation part, what I'm trying to explain you is that when we have this, so every circular motion has a moment of inertia. Moment of inertia. So, inertia and moment of inertia. What is this? Inertia is difference. Inertia means resistance to the forward motion, resistance to linear motion. Okay? Like if you are a heavy object, it will be difficult to push you forward. If you are a lighter object, it would be easier for you to move forward. But moment of inertia means resistance to rotate in the circular path. Moment of inertia means resistance to rotate in a circular path. Understood or not?
yes, but if the string is longer and it pulls more, it will have more inertia, and it will be easier to keep it going after you've started to rotate it.
But yeah, the starting part also is important, no? How could you not just start it? How would you start it? That's the point, no? To keep
Yes.
it going is the momentum. To keep it going is the momentum. But to start it and to keep it in the motion is moment of inertia. So the value of the moment of inertia is given by mr square. So that means I equals to mr square. Mr square. So that means this body m, and that's totally right. You can try it out. You take a long, long, long thread and you rotate it. There are high chances that that thread might, will go down. That thread might sink down. It might not remain straight.
I already tried with the thread this big.
Yeah. So did that move?
It was easier than with the smaller string
It was easier.
because I just had to start it. It took a few turns and then it was going very, very fast. And all I had to
How
do
did you
was
move
this
it? Like, did you move it in the horizontal circle or did you move it in the vertical circle like this?
both.
Both the ways it was easier for you.
The small string is easier to start, but keeping it going, you have to constantly do this.
Correct. Right. But that's a concept of torque in it. That's a concept of torque in it. So we are just talking about how easy it is to move. So that's the thing. Now you understand. So I is the starting situation. You can understand it that way. Do you understand?
Yes.
Okay. So I is the moment of inertia. Because once you move it, then it's a different story at all. But once the body is at rest, and to start its rotation, how much resistance it is imposing is mr square. Right? So that is m is the mass, R is the radius of the length of the thread or length of the axis. Okay. So from point O, this mass M is rotating. So you would say from O. Okay. The distance of the mass M is R. So what is small r? Small r is the distance of object from axis of rotation. Yes or no?
Yes.
Okay. So that is the concept. So my point here is that small r would be the distance of the object upon from the axis of rotation. So you see that I is equals to mr square. That's I. Are you understanding my point?
Yes.
So basically, in linear momentum, who decides the resistance? Only the mass. In linear motion, who decides the resistance? Who decides the resistance? Only the mass. Okay. But in the circular motion, who decides the resistance offered by the body? The mass of the body as well as the radius along which you're going to trying to rotate. Understood or not?
Yes.
Right? Okay. So now this is my moment of inertia. That means resistance to the rotational motion. Now you understand. One more thing is there. We have this circle, right? And we have this red circle. And this is the center. Whose center is O? Now there are two people. One at red circle A, one at black circle B. Now both of them moves, okay? You understand. So let's suppose I say that in 5 seconds, both of them moved and reached A to A dash and B reached from B to B dash. But
We
B,
traveled more.
yes, linearly, B traveled more. Linearly as in the longer the distance, the linearly B traveled more. Okay? And A traveled less. But my point is, angularly, actually, both of them traveled the same length. Both of them traveled 60 degrees in 5 seconds. Isn't it? Because if I take the starting position of A and if I take the ending position of A and I join them at the center, what angle do they make at the center, Mark? Let's
They
suppose
make a
60 degrees.
60-degree angle.
Correct. Let's suppose I started, you know,